Hello everyone. I welcome you all for the lecture series videos of mechatronics and automation. So in the previous video, we have discussed about the two-step mode, that is switching functions on and off, how it is accomplished with respect to the parameter change or the input variable is changing. So with respect to the input variable, the controlling functions can be enabled and disabled in the two-step mode. As a continuation of that video, we have another mode that is called a proportional mode. So proportional, that name itself indicates if the error value increases, then the controlling signal is also increases. So the magnitude of controlling signal is proportional to the error signal. So that is the difference between the two-step mode and the proportional. So let us have a detailed discussion on the proportional mode. So as we discussed earlier with the two-step mode, either we have on signal or off signal regardless of magnitude of error. Whenever the error is there, either it will produce on or off signal. It doesn't worry about the magnitude of error signal. If magnitude is more, uh, it just put on signal only. So there are some applications where the controlling signal it should be related with the magnitude of error. Immediately we need to address the problem. So such kind of applications we are the necessary to go with the proportional mode. Here the size of the controller the output is proportional to the size of the error, which means the bigger the error is, then the bigger uh, the output from the controller. So the controlling functions can be expressed in the following formula, that is the controller output is equal to Kp into E. That is output of the controller is proportional to the E, where E is the error signal. When you remove the proportionality, you have to introduce the constant of proportionality, that is Kp. So therefore, the output error is equal to Kp into E, where Kp is the proportional constant. So if you take the Laplace for this, we will be having a Kp into E of S, where Kp is the transfer function of the controller. So this is the circuit which explains the proportional mode. So here we have two voltages. One is input voltage and another one is error voltage. So this is sent it to the resistors, then and it is compared with the summing amplifier. So here the error signal and the output voltage is compared and it measures the amplitude of error signal. When there is an error signal increases, then the controlling signal is also increases and it is sent to the controller. According to the input received from the controller, the processing element increases the output and finally the process being controlled can be uh, controlled. So here the output voltage of the controller can be a function of Kp into VE plus VO. So the output voltage is depends upon the input voltage plus error signal into the proportional constant. Where Kp is the proportional constant. So by this way, the output signal of the controller can be increased proportionally with the help of error signal. In the previous case, where the two-step mode, whatever be the error signal, either it is a small error signal or it is a large error signal, it just gives the control signal. But here the magnitude of control signal or output of the controller is varying, that is proportional to the error signal. So that is the difference. And these are all the references for my presentation. One is Mechatronics, authored by W. Bolton, published by Pearson Education, second edition, the year of 1999. And my second reference, Mechatronics, authored by Bradley, published by Chapman and Hell, the year of 1993. So in this video, we have discussed about the proportional mode. How the proportional mode can be accomplished, how it is differentiated from the two-step mode. So in the proportional mode, we learned that the output signal of the controller is proportional to the error signal. So we are summing up the input signal with the error signal, which is uh, proportional with the constant, where Kp is the proportional constant. So I hope this video is useful for you. Thank you.